In the last two videos concerning vector analysis, we've been discussing Green's theorem in the plane, and we gave it not a real bona fide proof, but at least a good demonstration as to why this formula holds true, where if we have a closed curve and we take the line integral about that curve, it is equal to this double integral. And what we're going to do in this video is work a specific example. So here's how it's set up. In fact, part of the problem we had worked before, where we have this type of closed curve. We go from here along this parabolic arch where y equals 1/4 x squared, and then we are up here at the point 2, 1, then go back to the y-axis, and then go straight down to the origin. So what we will do is take the line integral about this closed curve here and pretend like this area is in a force field like this. And what you saw us do in our previous videos when we were working with line integral problems is take the dot product of the force field or the vector field in general with dr, where this is r is the position vector. Dr always has this general form. So f dot dr for our problem, this will be this line integral then of xy dx minus y squared dy. So we'll take this line integral going along here, then here, then here, take those three values and add them up. Now notice that for this problem, again, the line integral is usually expressed in this general form. P equals xy and q equals minus y squared. Xy and minus y squared. Now, we want to evaluate then over this curve. And we've done that problem before, so we'll just set it up in general. We have this xy dx minus y squared dy, where y equals 1/4 x squared, and dy, we can express that like this, 1/2 x dx. So substituting y and y squared with this expression and dy here, the integral becomes like this. I have an integral of x 1/4 x squared dx minus, and for this squared, that's 1/16 x to the 4th. dy is this, 1/2 x dx. Now everything is expressed in terms of x and dx. What are the limits? X goes from 0 to 2. And we worked this integral in a previous problem. It's straightforward, and the answer we obtained was 2/3. So for this part of the curve, the line integral is 2/3. Now we have to take the line integral here. So let's deal with that part. Now here, this is our integral, but obviously along this horizontal line, dy, that's going to be 0. So this is just 0. And along this horizontal line, y has a value of 1. So that's just 1. So we just have x dx. And now x is going from 2 to 0. So it looks like this. So this is 1/2 x squared 2 to 0. That will equal 1/2 0 minus 4. That's minus 2. So we have 2/3 minus 2, and now we have the line integral here. xy dx minus y squared dy, that's the general form, no limits yet. But here on this vertical line, dx is 0, so this is gone. So we just have minus this integral. And here, up on the horizontal line, y had a value of 1. So starting at 1, and we're ending up at 0. So this will be equal to minus 1/3 y cubed 1, 0. So this equals minus 1/3 times 0. 1 cubed is 1. So that's plus 1/3. So we have 1/3 plus 2/3 minus 2. That's minus 1. So this equals minus 1. So going around the entire curve, this, in which we of course designate with a closed circle, that integral has a total value of minus 1. Now what we want to do for this problem is take the double integral. So let's make some room and see if we get the same answer. We have this double integral. There's the partial of q with respect to x minus the partial of p with respect to y dx dy. And again, for this general form, it doesn't matter which order we put these. When we start doing the problem, looking with the specifics, then it will matter. Now, let's see. We have q, that was minus y squared. And p, that was x times y. When we were working with the line integral, we had xy dx minus y squared dy. The partial of q with respect to x, that's taking the partial of y with respect to x, that's going to be 0. And then the partial of p with respect to y, that's taking the partial of x times y with respect to y, that just equals x. So our double integral, this is going to be 0. We have minus x. minus x. Now, we can write it as dx dy or dy dx. Doesn't matter, but we have to think now about what we're doing. If we keep it in this form, that means, if you remember from our introductory videos on the Green's theorem, if it's dx dy, our double integral, that means now that we are using horizontal strips. So, let's keep it like this in this form. But that means then we're using these horizontal strips. So let's just draw one in like this. So x starts at 0 and it ends up out at this curve that has this equation. So x starts at 0. Now, what value does x have out here? Well, x squared equals 4 times y, so x will equal the square root of 2 times y. The square root of 2 times the square root of y. Let's do this again. It'd be 2 times the square root of y. X equals square root of 4 is 2. 2 times the square root of y. That's x. Going from here out to this curve. So here, x goes from 0 to 2 times the square root of y. And we add up all of these horizontal strips, starting down here where y equals 0, and keep going till y equals 1. So y goes from 0 to 1. So there's our double integral. Of course, this is going to be when we integrate the first one, the inner one. That's minus 1/2 x squared. So this equals, we still have this integral left, 0 to 1, but this gives us minus 1/2 x squared x goes from 0 to 2 times the square root of y. And then we have dy. So let's see what this equals. We have minus 1/2 times, now for x squared, we substitute this in. 2 squared, that's 4. So we have 4. The square root of y squared, that's y. And then just 0. So it's like this, and we have dy. So here we have 4 divided by 2, that's minus 2. So now we have minus 2, the integral from 0 to 1 of y dy. Of course, that's 1/2 y squared, so we have minus 2 1/2 y squared. Y goes from 0 to 1. This is minus 1. And this would just be 1. Minus 1 times 1 equals, of course, just minus 1. Put 1 in here. Of course, that's going to be minus 0. So 1 times minus 1 is minus 1. So doing the double integral comes out to minus 1, which is the same answer that we obtained when we did that line integral around the closed curve. So far, so good. What happens if we set up our double integral, and instead of having dx dy, we went the other way around and used dy dx? There's no rule against that. So let's see what that would give us. So now we're going to look at it like this. Double integral minus, we have minus x. Now we're going to write it as dy dx. And remember from 2 videos ago, when your double integral is in this form, now we're dealing with vertical strips. So we have to think differently. Now we have a strip that looks like this. So let's see how this works out. We have minus x dy dx. Now, y goes from where? It goes from this curve, where y equals 1/4 x squared, up to this horizontal line, where y equals 1. So y goes from 1/4 x squared up to a value of 1. So those are the y limits, and we're going to add up all these vertical strips starting here at x equals 0 and keep going until x equals 2. So now the double integral looks like this, having dy dx. And then we go ahead and we integrate. Now we're integrating with respect to dy. That means now that x just is treated like a constant. And for the moment, let's take this minus sign, put it to the outside. So for the first integral, the inside one is like this. X dy, x gets held as if it's just a constant. So this equals minus this integral, 0 to 2, and we have x, that's just treated like it's a constant, and the integral of dy is y. Okay, and y goes from where? From 1/4 x squared up to a value of 1, and we have dx. So let's see what this gives us. We have equals minus integral 0 to 2. We have x, and then we will have y equals 1, so we have 1, minus y equals 1/4 x squared. Dx. Okay, so this will equal minus the integral from 0 to 2 x dx minus 1/4 x cubed. Dx. So you have 2 integrals really, but they're pretty simple, so let's just keep it like this. This will equal minus 1/2 x squared. X goes from 0 to 2 minus 1/4. This would be x to the 4th divided by 4. X goes from 0 to 2. So this will be 1/16. We have the minus sign here, so let's make this plus. We have 1/16, 2 to the 4th. minus, now here we have this, which will be 1/2. 2 squared is 4. So it's like this. So here we have, this will equal 16 divided by 16 is 1, minus 4 divided by 2 is 2. 1 minus 2 equals -1. So, and again, that's the same as what same answer we had when we did the line integral and summed it about these curves. And we get -1 when we perform the double integral, regardless of whether we take it as dy dx or dx dy. Either way works. We just had to remember what we're doing in each case. If it's here, we have vertical strips, we have to remember how to set our limits. If we have dx dy, then it's horizontal strips, and we have to set up our limits in a different way. But either way, of course, it gives us the same answer. Okay, we'll try to have maybe a couple more problems here where we are dealing with Green's theorem and see if we can get some more practice. The playlist for these videos for vector analysis is at the website. The front page is under construction right now, but the playlist is at the website digital-university.org.